Hmm. Okay, mathematical expectation. The mathematical expectation of a discrete random variable x having values x1, x2 dot dot up to xn. This is the entries. Uh, Number of observations or number of arguments x1, x2 dot dot xn with respective probability. For x1, we get the probability of x1 px2 dot dot up to pxn. Probability of xn is defined by expectation of x. Summation will be I equals to 1 to n xi probability of xi. Okay, and sum of probability xi will be must be 1 because the highest probability is 1 and sum of all probabilities will be 1. This is the expectation formula, probability of expectation. So you have to remember this, the definition of mathematical expectation. Mathematical expectation ex equals to summation I equals to 1 to n xi probability of xi. This is the pxi, and sum of probability of xi will be must be 1. Remember it. And this definition we must have. The probability density function can be written as probability density function. Expectation of x equals to probability density function of f of x can be written as expectation x equals to minus infinity to plus infinity x f of x dx. Just replacing this probability of xi with f of x, then we get the probability density function of f of x. You have to use this definition in binomial distribution. Now look at the definition of binomial distribution. Now the properties of binomial distribution. Properties of binomial distribution. Mean, we have to find out first of all mean. Mean, we know mean mu equals to first corrected moments or raw moments. Which one here? Actually this is the raw moments. First raw moments equals to expectation of x. Expectation of x equals to a summation x equals to 0 to n and x of probability of x. This is the functional value x, and probability of x will be this. This is that from the definition of expectation. Now this can be written as summation x equals to 0 to n x probability of x summation I x equals to 0 to n and c. This is the actually this probability of x what? Binomial distribution function. Probability of binomial distribution function. This can be written as p of x equals to nx probability of x q to the power n minus x. This comes from where? By the definition of binomial, this probability of x, binomial distribution, right? Using this probability density function in replace of p of x, we can write ncx. There may combination and taking x from n number of things. P is the probability of success and q is the probability of failure. So p to the power x and x is the outcomes. Q to the failure outcomes will be n minus x. Q to the power n minus x. Just using this one in this in this expectation function, we get this. Now just nc, this is the nc r formula. R means x, right? Now if we already know that factorial n equals to what? N into factorial n minus 1, right? Factorial n equals to what? N into factorial n minus 1. And similar in this will be factorial x equals to what will be? X into factorial x minus 1. This is why this can be written as also n1 n minus 1 c x minus 1. This is the combination of n minus 1 and x minus 1. P to the power variable will be what? X minus 1, because we have changed this x. Probability of x minus 1 and this p p into a p to the power x minus 1 will be what? P to the power x only, and q to the power n minus x will be exist. Now this whole summation can be written as binomial expansion. By using binomial expansion, q plus p whole to the power n minus 1, where p plus q equals to 1. And because ncx combination of nx will be can be written as nx n minus 1x n minus 2 and dot dot up to and so on. We can write this is the combination formula. So this equals to only NP. Mean equals to only NP. We can find mean by this method also. We can use another method. Suppose this mean of binomial distribution. We can use also tabular method to find out the mean of binomial distribution. Suppose you must know this is the q plus p whole to the power n. This is the binomial expansion, right? Binomial expansion of q and p, and p is the probability of success and q will be the probability of failure. You know, must. So if this expansion can be written as this q to the power n and c1, q to the power n minus 1 p1, q to the power n minus 2 p square n minus 3 q n minus 3 p cube dot dot up to p to the power n. So we can table with 3 column. First column will be successor r and frequency. Second column, this is the product r into f. Suppose first will be start from 0, 0, 1, 2, 3 dot dot up to n. Summation will be x equals to what? 0 to n. This is why first of all we have to start with 0. If we take 0, 0, then what will be? Q to the power n, first term. For r equals to 0, what will be? First term. And for r equals to 1, what will be? Second term. And c1 means what? Only n. Q to the power n minus 1, probability of only p1. And product of this what? This multiply this. Product of rf, first column and second column individually multiplication will be here in the third column. 1 into this will be this. Now for r equals to 2 will be what? Third column. And third column nc2 can be written as n into n minus 1 by factorial 2. But factorial 2 means only 2. So q to the power n minus 2 into p square. And this multiplication 2 into this what? Only this 2 to cut, cancel. Now for r equals to 3 can be written as this. Actually this is the binomial expansion of individual r, right? Now for r equals to 3, what will be nc3? nc3 means combination formula, n into n minus 1 n minus 2 divided by factorial 3. Factorial 3 means what? 6, 3, 2, 1 multiplication. That will be 6. Now this multiplication, this what will be? Like this. 6 and 3 cut with 2. Now this will be the third column. Up to dot dot we get if r equals to n, then last term. If r equals to n, then this term will be the given value p to the power n, and this multiplication what will be npn. Understand? Now if we take summation fr, summation of this whole term, summation of fr, that means first term 0 plus second term plus third term plus fourth term up to n to the power n. Just taking sum. Now taking common np from every term, taking common np, then giving third bracket q to the power n minus 1, n and p cancel, so only n minus 1 and q to the power n minus 2 only p, single p. From this np will be take common, then this term, and after np taking common, what will be? P to the power n minus 1. You must know this is also the another binomial expansion of q plus p whole to the power n. Power will be just n minus 1. This series, this expansion same, just power will be what? N minus 1, right? Starting with power n minus 1 here, starting with power n minus 1 and replacing n by n minus 1 here. You get this series, this expansion. So this expansion can be written as q plus p whole to the power n minus 1, and q plus p means what? Probability of sum of probability, failure, sum of failure, and success will be what? Total probability is 1. This is why q plus p equal to 1 to the power something means only 1. This is why this is the np, and this is the mean of the what? Binomial distribution. This is another method, and this is also another method, finding mu. This is the one process. I hope this will be the very easier for you. This will be the more easier for you, right? Now mean will be what? Summation fr divided by summation f. This summation, if we divide with this summation f, what? Summation f frequency sum will be must be 1. because total probability 1. So summation f will be must be 1. And summation fr equals to what? This summation f equals to what? Only 1. And summation fr equals to only np. So np divided by 1 will be the give the mean of the binomial distribution. Now we will try to understand the standard deviation of binomial distribution. Okay, concentrate please. Similar process, we will draw a table with 3 columns. First column will consist of success or r, r values will be up 0 to n, and frequency column. Second column, if r equals to 0, this will be the first term. If r equals to 1, then will be the second column from this. This is the first term, and this is the second term. Okay, similar process, similar table. Okay, just r equals to 0 first term, this multiplication will be here. R equals to 1 second term of the binomial expansion, this multiplication will be this, and r equals to 2 third term, then multiplication will be this. If r equals to 3, then will be fourth term. After multiplication, this will be dot dot. If r equals to n, then frequency will be last term pn, and multiplication will be n p to the power n. Actually this is the product of what? R square p. Understand? This is the product of what? R square p. R square means what? Making square then multiplication. That means 1 square into this, 2 square into this, 3 square into this. Okay, so n square into this, what will be? N square p square. Just we have to make square this, then taking product individual rows, then we get this one, third column. Now we know that the standard deviation. Standard deviation equals to formula summation fr square divided by summation f minus summation fr divided by summation f whole square. That means this is the mean. Actually, we must remember this formula of standard deviation. Now r is the deviation of items from 0. That means r equals to 0 to n. So summation f what? Summation f 1. Summation f how 1? Summation f like this. This is why this equals to 1. We have already proved it. Summation f equals to 1. Now using this, and summation fr equals to what? Np. We have proved summation fr equals to what? Np. We have to write from this. We have to write from this. Okay. The summation fr equals to np. Then summation fr square equals to what will be? Now summation fr square. That means taking sum of this third column, all the values of rows in the third column, taking sum. Now summation fr square equals to 0 plus this plus this plus this plus up to n square pn. Okay. Now taking np common, taking np as common from all terms of the series, then np will be, there will be q to the power n minus 1. This will be 2 n minus 1 by factorial 1, like this. Now taking np common, we can write this series q to the power n minus 1. This can be written as n minus 1 into q to the power n minus 2 into p divided by factorial 1. Then n minus 1, n minus 2 divided by factorial 2, q to the power n minus 3, then p square plus dot dot up to just taking np from here, n gone in first, then p take, if we take p, then it will be what? p to the power n minus 1. Now p common, this is why power will be n minus 1. Now this twice, okay, 2 into n minus 1 divided by factorial 1 q to the power n minus 2 p twice. This is why this one 2 into this three term, this one term, this two term, this is why 3 term, sum of this. So we can write this series plus this series. Okay. Now taking common np, third bracket will be first term this n minus 1 q to the power n minus 2 with this, then just this term, writing this term. Now taking common from here n minus 1, in each term there will be n minus 1. Okay, now n minus 1 taking common, and p also can take common, so it will be q to the power n minus 2, n minus 1 can gone, p1 p gone, this is why n minus 2 into q to the power n minus 3 into p, then this factorial 2 in these two cut, this is why only 1 divided by 1 factorial, and this is divided by 2 factorial. This is also a binomial expansion on power what, n minus 2, and this is the first binomial expansion of with power what, n minus 1. So np into, we can write q plus p whole to the power n minus 1, right, plus n minus 1 into p, q plus p whole to the power n minus 2. This is the binomial expansion of with power what, n minus 2. So q plus p equals to 1, np into 1 plus n minus 1 into p. Okay, q plus p equals to what, 1 to the power something, 1 to the power something will be always 1. So np into np plus, when just taking addition and subtracting, we get this np into np plus q. Now n square p square plus npq. Now putting these values in equation 1 in the standard variance, standard deviation, sigma square will be variance. Just putting the values, summation fr square divided by summation f, and summation fr by summation f will be whole square. So and these values n square p square plus npq will be this, and summation f will be 1. Now summation fr equals to np from the above table, summation f equals to 1, this was just squaring. Now taking this all together, we get npq. So standard deviation will be just taking a square root. If we take a square root of variance, then we get the standard deviation square root npq. So hence the binomial distribution, mean will be np and mu2 will be what, sigma square equals to npq. This is the second corrected moment. Second corrected moment and variance same, right? Second corrected moment and variance same words. Understand? Okay, now this example 10, find the first 4 moments of the binomial distribution. We have to find out 4 moments, first 4 moments of the binomial distribution. First moment about origin, that means raw moments. This will be formula, what will be, r equals to 0 to n ncr p to the power n q to the power n minus r. This is only r. That means it's come from binomial distribution. NCR can be written as NCR n into n minus 1 n minus 2 dot dot up to n minus r minus 1. That means n minus r plus 1 divided by r factorial. Combination formula, NCR formula, p to the power q to the power n minus r, and this r comes in first. Now n into, just taking n in first, r equals to 1 to n and n minus 1 to this n minus r factorial. N minus r, taking n minus r factorial. How can you tell n minus r factorial? How? Actually r factorial into n minus r factorial. This, there is a mistake in this formula. There will be n minus r factorial. Okay, so r factorial and this r will be cancelled. R factorial can be written as r into r minus 1 factorial. This is why r into r minus 1 factorial. Now n into r equals to 1 to n and n minus 1 to this, and n minus r factorial p to the power r q to the power n minus r. This np. If we take p, 1p from here, then power will be what, r minus 1. Power will be r minus 1. Then actually this series can be written as what, n minus 1 c r minus 1. Actually there is a mistake, r minus 1 is absent. You have to write r minus 1 here. Combination formula just. This is the formula of n minus 1 c r minus 1. Understand? And power will be, p will be r minus 1 because there is a another p. So this is the binomial expansion of what, p plus q whole to the power n minus 1. That means it will start from n minus 1. This y can be written as q plus p whole to the power n minus 1. This equals to what? Only np. So first raw moments, that means moment about origin equal to np. Now for the second moment, about origin mu2 dash equals to r equals to 0 to n ncr p r q n minus r, just r square, taking r square. Now taking r square as r into r minus 1 plus r, right? R square can be written as r into r minus 1 bracket plus r. Now summation r equals to 0 to n r into r minus 1 plus r, just in replace of r square we writing this. Now taking distributing this to both term, r into r minus 1, and here will be only r. Now r into r minus 1, then ncr formula what? N into n minus 1 factorial n minus r plus 1 divided by factorial r. Here also n minus r another, n minus r will be comes. So p to the power r and q to the power n minus r. Then this series also can be written as like this. There will be plus sign. R equals to 0 to n r into n minus n into n minus 1 n minus 2 dot dot n minus r plus 1 divided by factorial r p to the power r q to the power n minus r. Same combination formula and same power here, pr and q to the power n minus r. Now n into n minus 1 taking in first, then taking p square from this p. If we take p square from this p, then we have to write p to the power r minus 2. Okay, p square into p to the power r minus 2 what? Only p to the power r. Okay, base same, power adding, then p to the power r minus 2. P to the power r becomes p to the power r minus 2 when we take p square as common. Then it will be start from what? N minus 2. Now if we take p, then this p to the power r will become what? P to the power r minus 1. Just all are same. Okay, just np. So this is the series of what? Binomial expansion of q plus p whole to the power n, starting from n minus 2, and this is starting from n minus 1. So q plus p whole to the power n minus 1. So q plus p whole to the power something equal to 1. This is why it can be written as n into n minus 1 p square plus np. This is the what? Second correct second raw moments or moments about origin. Similar process we can write third moment about origin equals to r equals to 0 to n and cr p to the power r q to the power n minus r. Same binomial expansion formula, binomial distribution p of x formula, and r cube here because third moment r cube. Now r cube can be written as r cube can be written as r into r minus 1 r minus 2 plus 3 into r into r minus 1 plus r. Okay, if you calculate this, we get r cube from here, r into r minus 1 r minus 2 plus 3 into r minus 1 plus r. Okay, just taking this as a sum. Now ncr p to the power n q to the power n minus 1. This is the binomial distribution function of probability, binomial distribution probability function. Now this term, there actually three term here, taking this multiplied with three term, first this, second one this, third one this. Now just putting ncr formula n into n minus 1 dot dot n minus r up to r factorial and n minus r also here. Okay, now p to the power r q to the power n minus r, just first one. Similarly from second 3 into this, just ncr formula, just then p to the power r q to the power n minus r. From this, from the last one, r will be in this and ncr formula this p to the power r q to the power n minus r. So this first term can be written as n into n minus 1 factorial r can be written as r into r minus 1 r minus 2 into r minus 3 factorial, right? R into r minus 1 r minus 2 r minus 3 factorial can be right. Okay, so r minus 1 r minus 2 will be cancelled from up and down. So this can be written as breaking r factorial, we get r minus 3 factorial. R minus 2 r minus 1 r minus 2 will be cancelled from numerator and denominator. So this and this same. Now from r factorial, r into r minus 1 into r minus 2 factorial. Okay, r minus 2 factorial. So r and r minus 1 will be cancelled from numerator and denominator. This term will be same as this. Now this r factorial, we can take r into r minus 1 factorial. Okay, r cancel, only r minus 1 factorial. All are same, all parts are same. So from the first one, now from the first one, this one we can write n into n minus 1 and minus 2 in the first. Then it will be start from what? N minus 3. So n minus 3 c r minus 3 factorial. This is why. So n minus 3 and r minus 3 factorial, NCR formula. Now taking p cube, we have to start from r equals to 3. This is why taking p r minus 3, then we get p cube in first. Okay, taking p cube in first, we can write p to the power r minus 3, p to the power r minus 3. In the second term, taking p n into n minus 1 in the first, taking common, because it will start from what? N minus 2, because r minus 2 factorial. So this is the formula of n minus 2 c r minus 2, and power of p will be what? R minus 2, because it r equals to 2 starting. This way p square taking common, then we have to write this p as p to the power r minus 2. Similarly, third one will be p to the power r minus 1, because starting equals to r equals to 1, starting from r equals to 1. This is why, and n will be comes in first, and p also comes in first, and then n minus 1 c r minus 1 factorial. Then this p will become what? P to the power r minus 1, then q to the power n minus 1. So this is the actually binomial expansion of q plus p whole to the power n. That means this power start with n minus 3. This is why power will be n minus 3, and this power start with n minus 2. This is why q plus p whole to the power n minus 2, and this will be the power n minus 1 of the binomial expansion of p plus q. Understand? Just q plus p whole to the power something equals to 1, then we get this one. Now taking multiplication, or this is the third one, third moment about origin, or third raw moments. Now fourth moment, similarly we can found mu4 equals to just r4. We have to use r4, but this r4 can be written as like this: r into r minus 1, r minus 2, r minus 3. After multiplication we get r4, then 6 r into r minus 1, r minus 2, plus 7 r into r minus 1. Okay, then taking multiplication with this every time. Now r minus 1, r minus 2, r minus 3 will be cancelled from here, r factorial, because r factorial can be written as r into r minus 1, r minus 2, r minus 3, r minus 4 factorial. Okay, r minus 4 factorial. So r minus 1, r minus 2, r minus 3 will be cancelled from numerator and denominator. So this term can be written as this. And here from the first one, this is the r minus 4 factorial, first one, and all are same. Similarly, from the second one, r minus 1, r minus 2 will be cancelled from r factorial. The r factorial will become what? R minus 3 factorial. From the 7 into the r into r minus 1 will be cancelled from r factorial. So this r factorial will become r minus 2 factorial. All are same. Then the last one, this r factorial, r will be cancelled by r factorial. What? This will become r minus 1 factorial. Now using similar process as before, n into n minus 1, n minus 2, n minus 3, then r equals to start with what? 4, because r minus 4 factorial. R minus 4 factorial. This is why r will be start from 4. Now all term before 4 will be here. So n minus 4 start with what? N minus 4 c r minus 4, and this p will be what? This p will become start with 4, because r minus 4 we have to write r minus 4. This p will be taking p4 common, taking p4 common is like this. Taking p4 common, we can found p to the power r minus 4. Okay, and q will be what? Q will become q to the power n minus 4 minus bracket r minus 4. That means n minus r, same. N minus 4 minus r minus 4, same n minus r. Okay, this is why you can write this as a binomial expansion of this. Similarly, n minus 3 c3 can be written as this pq plus p whole to the power n minus 3, and taking p cube common to this, taking p cube to common this. Now taking p square common to this, p to the power r minus 2 will be r minus 2 nc2 c r minus 2. This is why we can write the power will be n minus 2, n minus 2 binomial expansion. So and the last term will be also p to the power r minus 1, taking p in first np into q to the power same formula we are using. Then q plus p equals to 1 whole to the power n. So 1 whole to the power something will be 1. This is why writing this one. This is the fourth raw moment, or fourth moment about origin. Understand? Moment about origin or raw moments calculated. Now central moments, that means amount about mean, that means corrected moments. This is also corrected moments. The first 4 central moments are obtained as follows. That means mu2 second corrected moments equal to mu second raw moments divided by first raw minus first raw moments, right? This comes from where? Relation between raw moments and corrected moments. We established the relationship between raw moments and corrected moments before. So using this relationship, second corrected moments equals to second raw moments minus first raw moments. Just putting these values from here, from these values. Now putting just giving the values, we can calculate. And 1 minus p equals to what? P plus q equals to 1. This is why 1 minus p equal to q, right? Just npq, putting these values. Now variance of the binomial distribution is npq. This is also variance, and this is also second corrected moment. That means second moment about mean. Remember it. This is also called central moment. Moment about mean. This is why central moment. Now third central moment can be calculated as mu3 equals to third corrected moment minus 3 into second corrected second raw moments into first raw moments plus 2 into first raw moment whole cube. So just putting the previous values. Okay, mu3 dash, this calculated this one minus 3 into mu2 values and pq, just then mu2 mu1 first raw moments 2 into first raw moments whole square whole cube, just putting the values. Now calculation. Now multiplying this, taking np common, then if you take 3 np common, then 1 minus p. 1 minus p equals to q, always remember, because p plus q equals to 1. Just we get this one. This is the third central moments, or third moment about mean. Now fourth central moment can be calculated as just mu4 equals to mu4 fourth corrected moments, or fourth moment about origin, sorry, fourth moment about mean. This is the central moment. So mu4 fourth raw moment minus 4 into third raw moment into first raw moment plus 6 into second raw moment into first raw moment whole square minus 3 into first raw moment whole to the power 4. This is from the relationship between raw moments and corrected moments. You have to remember this formula, and you have to use this relationship in every higher, in every distribution, probability distribution. Now just putting the above values. This is the mu4 dash values, these values, and mu3 dash values, that means third raw moment, and this is the values of second raw moments, and this is the value of first raw moments, only np. So putting these values in the fourth central moments, we get this value. Try to calculate this, try at home. I hope everybody can do this. just multiplication, addition, and using formula n minus p equal to q. That means p plus q equals to 1. Now the kurtosis beta coefficient. Carl Pearson's beta coefficient can be calculated as first beta coefficient beta 1 equals to mu 3 whole square divided by mu 2 cube. Now just putting the values of mu 3. Okay, mu 3 values what? This one. This will be the mu 3 value, npq q minus p. Okay, and this will be the mu 2. This will be the mu 4 dash, and this is the mu 2 npq, and this is the mu 3. Then putting these values, we get what? Beta coefficient, Carl Pearson's beta coefficient. That means kurtosis beta 1 equals to mu 3 whole square divided by mu 2 cube. Just putting these values we get. Then gamma coefficient also equals to square root beta 1. Just taking a square root of this one. Now coefficient of kurtosis can be calculated as beta 2 equals to mu 4 divided by mu 2 whole square. Just putting the values of mu 4. Okay. Now mu 2 whole square equals to mu 2 means npq. This is the also variance. This is also variance. This is why just calculating this we get. Now again we know gamma 2 equals to beta 2 minus 3. Okay. Gamma coefficient. Carl Pearson's gamma coefficient, gamma 2 equals to this. Just beta 2 equals to this, taking 3 minus, we get only this one. This is very important for you. Calculating kurtosis. Then calculating four central moment and 4 raw moments. This is very important for us. Calculating, finding first 4 moments. That means first 4 moments will be origin, about to origin or raw moments, and another is central moments or corrected moments or moments about mean. Remember it. Example, first example 11. If the probability of a defective bolt is 0.1, defective bolt probability is 0.1, and find first of all the mean. We have to find out the mean, the standard deviation for the distribution bolts in a total of 400. That means n equals to what? 400, and probability p equals to 0.1 for the defective bolts. Now we know mean. First of all, we have to find out the mean. Mean equals to np. This is from the binomial distribution properties of binomial distribution. Mean equals to np. We get this one. Now standard deviation square root npq. That means square root of our variance. From the properties of binomial distribution, we get this. Q equals to what? 1 minus p. P equals to 0.1. 1 minus p is 0.9. Just putting the values, we get the result. Now another example. A die is tossed thrice. So n equals to what will be? 3. A success is getting 1 or 6 on a toss. Find the mean and variance of the number of successes. Now actually in dice, how many observations? 6. Favorable, how many spaces? 6 spaces. Our favorable will be what? Favorable will be 1 or 6. Favorable will be 2. That means 2 by 6 will be the probability. So probability will be 1 by 3. 2 by 6 means what? 1 by 3. Now q equals to what? 1 minus p. 1 minus p equals to what? 2 by 3. So mean equals to np. Just putting these values, and variance npq. This one. Clear? Clear, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Now example 13. If mean and variance of a binomial distribution are this and this, actually mean are given and variance also given. Find the probability of exactly 2 successes in number 2, less than 2 successes in number 3, at least 2 successes. We have to find out 3 conditions, but our given, we are given mean equals to 4. That means np equals to what? 4. From binomial distribution, mean equals to np. Now variance equals to also given 2. from binomial distribution, np equals to 2. That means equation 1 and 2. Now dividing 2 by 1, we get q equals to half. Then p equals to also found. P equals to half, q equals to half. Now putting the value of p in equation 1, we get the number of successes, number of observation, total number of observation, n equals to 8. Now we have to find out the first one, probability of r successes. We know the probability of r success is what? NCR, p to the power r, q to the power n minus r. This is the probability distribution function, probability density function of what? Binomial. Remember it. So we have to find out exactly 2. This is why r equals to 2. Just putting r equals to 2 here, we get this one. This is the result. Now probability of less than 2 successes. Less than 2 means what? Probability of 0 plus probability of 1, right? Probability of 0 less than 2. This is why probability of 0 and probability of 1. So for r equals to 0, we get this one. For r equals to 1, we get this one. Just putting the value of pq, we get this result. Now at least 3 successes. At least means what? At least means we can take more than 2. That means probability of 2 plus probability of 3 up to probability of 8, because our total number of n is what? 8. This is why at least 2 means probability of 2 plus probability of 3 plus dot dot probability 8. This whole can be written as probability of 0 plus probability of 0. If we start from probability 0 plus probability of 1, probability 2 up to 8, then just taking minus probability 0 and probability 1. This whole probability what? Total probability we know 1, right? Probability, total probability what? 1. Then taking minus probability of 0, probability 1. If we take 1 minus probability of 0, probability of 1, then we get this probability, right? Now putting these values, we get this result. Now if we take binomial distribution for the following data and compare the theoretical frequencies with the actual ones. There is a given data, x values this and y values this. For every values, this is the actually sequence values, x0, 1, 2, 3, 4, 5, 0 to 5. Now y equals to f will be this. This is also given up to 8, and total summation f equals to what? 100. Taking sum. Now fx multiplication, just taking multiplication, and this also summation. So probability, this probability actually total sample what? How many? 5 CR, 5 CR, p to the power 5, p to the power r, q to the power 5 minus r. Okay, 5 minus r. Now if x equal r equals to 0, r equals to 0 means this 5c0. P value what? P value what will be? And q value what? Actually summation f equals to 100 from this table, and summation fx will be total what? 284. Now mean equals to what? Summation fx, summation f. Okay, 2.84. This is the mean. Mean means what? This sum divided by total number of frequency. Total number of frequency what? 100. So we get only 2.84. Now mean equals to np from the properties of binomial distribution. So np equals to this. Again, we have observation, total observation what? N equals to 5. This is why 5p equals to this. Now we can probability of this 0.5868. That means p equals to 8. P equals to 0.568. Now q equals to 1 minus p, right? So the value of q will be 0.432. Now substituting these values in the fourth column. Okay, for every value of x equals to 0, r equals to 0, p q this, r equals to 1, p q this, and r equals to 2, p q this, and up to r equals to 5, then 5c5, p equals to p to the power 5, q to the power 0. Okay, n minus r, that means 5 minus 5 equals to 0. This is why. So this calculate, after calculating by using a scientific calculator, we get these values. Now theoretical frequencies. Theoretical frequencies what? Actually multiplying 100%. Then 1 theoretical multiplying this just 100, then we get this one. So the binomial distribution is this 100 plus 0.432. 432 plus 0.568 p plus q whole to the power 5 na, p plus q whole to the power 5, right? Or sorry, q plus p whole to the power 5 n binomial distribution. This is the result. Very easy. Okay, 7 coins are tossed and number of heads noted. The experiment is repeated 128 times. 128 times. Remember, the following distribution is obtained. Number of heads for r equals to 0, 1, 2, 3 up to 7. Then frequency will be 7. 6, 19, 35, 30, 23, 7, 1. Total will be what? 128. Fit a binomial distribution, assuming the coin is unbiased. First condition what? The coin is unbiased. Second condition, the nature of the coin is not known. Okay, the nature will be not known. Number 3, the probability of head for 4 coin is this, and for the remaining 3 coin is this. Now we have to find out the solution of this. In fitting the binomial distribution, first of all, the mean and variance of the data are we must know from the properties of binomial distribution. Mean will be NP and variance will be NPQ respectively. Then the expected frequency can be calculated, and here n equals to 7. Total number of sample 7, and capital N equals to 128. This is the actually number of experiment. Total number of experiment, capital N. So when the for the first case, when the coin is unbiased, so PQ equals to what? Half. Probability will be what? In coin, there are only 2 outcomes. One is head and other is tail. This is why probability of each what? Probability of success and probability of failure equals to same. So P of 0 equals to Q to the power N from the binomial distribution, right? And f of 0 will be what will be? Similarly, n into Q to the power N. N equals to total number 128, and Q will be half to the power 7. This is also 1. Now using the recurrence formula from the above probabilities, probability P1, P2 can be calculated as like this. X equals to this, and n minus x divided by x plus 1, n minus y, x into x plus 1 into P by Q. Expected frequency f of x equals to n into probability of x. X equal to 0 to up to 7, and n minus x divided by x plus 1 will be just putting the value of n and x. We get this one. So multiplying with this P by Q. P by Q means what? 1. P by Q equals to 1, because each probability, each success and failure, P equal to Q equals to half. This is why P by Q equals to what? Only 1. This is why same. P by Q equals to same values give. Now expected values f of x equals to n px. This is the probability distribution function for binomial. The npx we can calculate f of 0 equals to f of 0 equals to this, then n into p to the power 0. N equals to what? A p of 0, probability of 0 what will be? 1. Probability of 0 equals to f of 0. F of 0 equals to 1. Now f of 1 what will be? 1 will be 1 into 7. Then f of 2 equals to 3 into 7. F of 3 equals to 21 by 5 by 3. This equals to 35. F of 4 equals to f of 5 equals to, just put using the same formula of binomial distribution. Then we get up to f equal to 7, r equals to 7. The f of 7 equals to 7 into this 1 by 7. This equals to only 1. Now this is the table for the first case. Now when the nature of the coin is not known, np mean equals to what? 1 by n summation fi xi. This is the formula of mean, and this equals to total divided by 433 divided by 128. 433 divided by 128. This total. This will be give only 3 point, n equals to 7. N equals to 7 given. So probability p equals to n equals to 7. This is why probability p equals to 0. This. Just dividing this with what? 7, then we get 0.48326, and q equals to what? 1 minus this is, so p by q equals to, in this case, this. For when the nature of coin is not known for types of coin, then p by q equals to this. Now f of 0 equal to n into q to the power 7, n into q to the power 7. This is the using logarithm, actually power 7. This is why. Now similar process in this case, f of x equals to n probability of x, probability of x. Similar process, f of 1 to up to f of 7. This p by q equals to what? This value only, this value, using n minus x divided by x plus 1, multiplying this, each term multiplying. Then we get this table. Now the probability of generating function, probability access for the 4 coins, and probability of this the remaining 3 coins. Actually there are 7 coins are given by this q plus p whole to the power 4, binomial expansion, q plus p whole to the power 4 for 4 coin, and they for 3 coin, q plus p whole to the power 3. Since all the truths are independent, this means individually happen. Probability generating function for the whole experiment is given by this is the just multiplication, taking multiplication, taking all together, so we get this one. Now f of x equals to n into coefficient of t to the power x in this. So putting the f equal to 0 to up to 7 in this coefficient of t to the power x in this series. So a little bit hard for you maybe. If you do practice, I hope everybody will understand. Otherwise, I will repeat it in the next lecture. You can use this method also. Also, you can use this method also. BK Kapoor book, this one. You can also, same process, same procedure. This is the 128. The second one, same procedure. P by Q equals to what? This one. Then for the second table, this is the expectation. This is also total 128.
হ্যাঁ স্যার
হ্যাঁ, r equals to 0 1 2 3 4, just চারটা। r equals to 1 2 3 4, এখানেও এখানে এইগুলো আর এর মান, এগুলো একটু চেষ্টা করবে আর কি, বাইনোমিয়াল ডিস্ট্রিবিউশন ইউজ করে দুটা হোমওয়ার্ক। ওকে, তাহলে আজকে এই পর্যন্ত থাক। তোমরা নেক্সট ডেতে সবাই একটু আসবে নিয়ে, তখন আমরা নিউ একটা ডিস্ট্রিবিউশন